Hi there, this is Module 13, Part 2. Get your textbook out and your notes and get ready to take notes and follow me along. On page 484 of your textbook, if you want to turn to that, there's some really neat pictures there. There's a diagram of the layers of our atmosphere. So we're just going to go through those real quick. So here's Earth, and our first layer is what? The troposphere. And what's special about the troposphere? Well, that's where we live, right? That's where mountains are. Jets fly in the troposphere. That's where the moisture is, and so that's where we're going to have clouds, and that's where we're going to have weather. Remember what a temperature gradient is? It's just a gradual change in temperature. And if you've ever traveled to Mount Spokane on a hot summer day, you would have noticed that it gets much cooler as you get to the top of the mountain. Well, we live in the troposphere, and the troposphere is characterized by a drop in atmospheric pressure as the altitude increases. So as you go higher up, the pressure gets lower, and also there's a drop in temperature as your altitude increases. So the higher up you go, the lower the temperature. Okay, so in general, every kilometer higher in altitude, you're going to drop 6.5 degrees Celsius in temperature. And this makes sense because as altitude increases, there's less gases for the sun to warm and there's fewer molecules absorbing the energy. And so that's why we see snow at the tops of mountains in the summer still. The tropopause is the section that separates the troposphere from the next layer, the next altitude layer, which is the stratosphere. And it's about 11 to 12 miles up above the Earth's surface. This is where an unprotected person would lose consciousness from the thin atmosphere, and they'd freeze to death too because it'd be so cold. Mount Everest is 5.5 miles in elevation, and it's very cold, and hikers have to carry their own oxygen with their gear. So we have the troposphere, we have the tropopause, which is just the section that separates them. Anytime you have a pause in between the layers, that's what that is. And then you have the stratosphere. And there's something special about the stratosphere. We have the ozone layer. It's kind of in the middle of the stratosphere. So the temperature gradient actually reverses at the ozone layer. So normally it would go colder and colder as you increase in altitude, and the amount of greenhouse gases decrease, but until you reach the ozone layer. And then the temperature gradient reverses, and instead of getting colder and colder, it's going to start to get warmer and warmer. Starting at the ozone layer, the total amount of air still decreases with altitude, but there's an increase in one type of gas, and that is ozone, which is actually O3, 3 oxygen molecules bonded together. And the ozone is what protects us from the UV rays by absorbing them. Okay, so if the ozone is absorbing energy from the sun, it's going to become hotter, right? And so ozone decreases at the stratopause, which is the separation of layers where the stratosphere ends and the next layer begins. And the temperature begins to decrease in the mesosphere. Next, we have the mesosphere, and it starts with an M, and this is where the meteors are burning up in. Next is the thermosphere, and at the thermosphere, there are very few air molecules. However, each one of those air molecules has a very high amount of energy from the solar radiation, from it absorbing that energy. But a thermometer would actually read a low temperature because there's not enough air molecules to bump into the thermometer. And if you were in the thermosphere, you would feel cold. But if you define temperature as the amount of kinetic energy, then the temperature is actually very high in the thermosphere. So remember, thermo is heat, so thermosphere, you can think of it that way. Next is the exosphere, and this is the last one, and it's the same thing there, but with even fewer air molecules, and the temperature fluctuates greatly by day and night. The International Space Station orbits in which layer, do you think? It actually orbits in the thermosphere or the lower exosphere. Another layer that you might hear talked about is the ionosphere, and this actually encompasses 3 layers of the atmosphere: the mesosphere, the thermosphere, and part of the exosphere. So when an atom becomes electrically charged, it's an ion, right? And when an atom becomes an ion, we call it ionized. Here is where the solar radiation ionizes gases. This is also where radio signals travel. So radio signals travel in straight lines, and they're part of the electromagnetic spectrum, remember, and they can increase their range by actually bouncing off of the ionosphere. Parts of the ionosphere overlap with the Earth's magnetic field at the north and the south poles, and so this is where you're going to see the aurora borealis or the aurora australis, the northern lights and the southern lights. I wanted to just show you something here about the temperatures. So you see the troposphere, and you can see that this is 0 degrees Celsius right here, and then it gets colder. So as you increase altitude, it actually gets colder. It's going into the negative degrees Celsius, okay? And then you hit the ozone layer, and now it's getting warmer, 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 warmer. Strata pause, and now it's getting colder in the mesosphere, colder, colder, colder. And then in the thermosphere, how we measure temperature is by how much energy is in each molecule. So now the temperature is actually increasing, increasing, increasing. If you look at the picture on 484, you'll also see the homosphere mentioned and the heterosphere. If you think of homosphere like our home, it includes that troposphere where we live, and also the stratosphere and mesosphere. And the air here, depending on your altitude, is fairly uniform in composition. It is mostly oxygen the lower down, and then as you go higher up, it becomes mostly helium, and then it adjusts to being mostly hydrogen as you go even higher up. And then the heterosphere, the air is not uniform there, and that is the thermosphere and the exosphere. And then page 489, it kind of talks about other planets, atmospheres, and what they're looking for with these probes that they're sending out, NASA, to find basically oxygen, because it's a very necessary gas for life. Also, water, liquid water is necessary for life, and I would say CO2 also for plant life. So that's what they kind of look for evidence of on these other planets. We'll see if they ever find life. God created our Earth just perfectly for us, so I'm not sure they will, but they can keep on trying because science is great. Keep asking questions and keep looking for answers. All right, thanks for watching.